So lastly, let's suppose that I've got my coordinate plane. Here's my I didn't draw the whole axis, but this is my x-axis, this is my y-axis. And now let's take my 30-degree triangle and let's place this particular triangle with the vertex of 30 degrees at the origin. So let's suppose that this is my 30 degree. So remember, the side opposite the 60-degree angle is square root 3 over 2, which is the length of this side of my triangle. The height is the same length as the side opposite the 30-degree angle, which is a half. So notice I can find the ordered pair right here. The x-coordinate is square root 3 over 2. The y-coordinate's a half. So now notice, and of course we know that the hypotenuse of all these were 1. Next, let me put my 45-degree triangle. So my 45-degree triangle, where notice I knew the height was square root 2 over 2. The length of the horizontal side was square root 2 over 2. So I could find this ordered pair as square root 2 over 2, square root 2 over 2. Then finally, let's suppose I put my 60-degree, and I'm just going to draw that 60-degree triangle again because it's getting a little bit squished here. So there's 60 degrees. Hypotenuse is 1. Notice the horizontal side of the triangle is the same length right here, which is a half. The height is this side of my triangle, which is square root 3 over 2. So I can find this ordered pair in the coordinate plane. The x-coordinate is a half. The y-coordinate is square root 3 over 2. So keeping this as a reference, this chart we're going to fill out using what we know with the 6 trig ratios. Let's take a look at the sine of 30 degrees. So the sine of 30 degrees, remember, I know is the opposite, which is a half, over 1, or 1/2 divided by 1, which is 1/2. The cosine is the adjacent over the hypotenuse, which is square root 3 over 2 over 1, or square root 3 over 2. Tangent is the opposite side divided by the adjacent side. So now the opposite side was 1/2 divided by the adjacent side. So 1/2 divided by square root 3 over 2. So 1/2 times 2 over square root 3. So I end up with 1 over square root 3, or when I rationalize that, that's square root 3 over 3. So now that I know those 3 trig functions, I can find the reciprocals. Cosecant is the reciprocal of sine, which is 2. Secant is the reciprocal of cosine, so that's going to be 2 over square root 3, or times square root 3 over square root 3, so that's going to be 2 square root 3 over 3. Cotangent is the reciprocal of tangent. Again, don't flip the fraction that before you rationalized it. Flip 1 over square root 3, which is just square root 3 over 1, or just square root 3. 45 degrees. So 45 degrees I know is the opposite over hypotenuse. That's just going to be square root of 2 over 2. Cosine is the adjacent over hypotenuse, so that's also square root of 2 over 2. Tangent, remember, is the opposite over adjacent. Well, anything divided by itself is just a 1. Cosecant is the reciprocal of the sine, so that's going to be 2 over square root 2. Rationalize that. That's going to be 2 square root 2 over 2, or just square root 2. We already rationalized, so secant goes with cosine. I've already done the flipping, so that's also going to be square root 2. Cotangent is the reciprocal of tangent. Remember, the reciprocal of 1 is just 1. So finally, my 60 degrees. 60 degrees, remember, is the opposite over hypotenuse. So the sine of 60 degrees is just going to be square root of 3 over 2. Cosine is the adjacent over hypotenuse. So 1/2 divided by 1 is 1/2. Tangent, remember, is the opposite over adjacent. So if I take the square root of 3 over 2 divided by 1/2, I know when I divide fractions, I'm going to multiply by the reciprocal. That's just going to give me square root of 3. So now cosecant is the reciprocal of sine. So the reciprocal of square root 3 over 2 is 2 over square root 3. So that's 2 square root 3 over 3. Secant is reciprocal of the cosine, which is just 2. Cotangent is reciprocal of the tangent. So reciprocal of square root 3 is 1 over square root 3. And when I rationalize that, that's going to be square root of 3 over 3. These are true for all special right triangles, not just a 30, 60, 90, or 45, 45, 90. What you've actually just done is I've done an introduction to what the unit circle is going to look like when we start talking about the foundation of trig, which is our unit circle.